Network devices. In modern computer networks, data does not move on its own. It relies on specialized hardware known as network devices to transmit, receive, manage, and control the flow of information across different transmission media. To build networks with varying sizes, speeds, and functions, different devices are required. Each device plays a specific role, from enabling basic connectivity to directing traffic across complex global networks. In this section, we will explore the core network devices that make communication possible. These include the modem, hub, switch, repeater, router, gateway, and more. We will examine how each device works, where it is used, and why it is essential in modern networking. By the end of this lesson, you will have a clear understanding of how network devices collaborate to form reliable, secure, and efficient communication systems. Modem. Modem stands for the modulator-demodulator. It refers to a device used for conversion between analog signals and digital bits. We know computers store and process data in terms of zeros and ones. However, to transmit data from a sender to a receiver, or while browsing the internet, digital data are converted to an analog signal and the medium, be it free space or a physical media, carries the signal to the receiver. There are modems connected to both the source and destination nodes. The modem at the sender's end acts as a modulator that converts the digital data into analog signals. The modem at the receiver's end acts as a demodulator that converts the analog signals into digital data for the destination node to understand.
The diagram illustrates the working principle of a modem and explains how digital data is transmitted over an analog communication medium, such as a telephone line. It shows the complete process of modulation and demodulation between two digital devices. Explanation of the diagram. The diagram represents two computers communicating with each other through modems using a telephone line as the transmission medium. Since computers generate and understand digital signals, and traditional telephone lines are designed to carry analog signals, a modem is required at both the sending and receiving ends. Sending side, modulation. At the sending end, the computer generates data in the form of a digital signal, which consists of discrete binary values, zeros and ones. This digital signal cannot be transmitted directly over a telephone line. The digital signal is therefore passed to a modem, modulator-demodulator. The modem performs modulation, which is the process of converting the digital signal into an analog signal. This analog signal is suitable for transmission over the telephone line. Transmission medium. The modulated analog signal travels through the telephone line. During transmission, the signal may pass through long distances and various network components while maintaining its analog form. Receiving side, demodulation. At the receiving end, the analog signal arrives at another modem. This modem performs demodulation, which converts the received analog signal back into a digital signal. The recovered digital signal is then sent to the receiving computer, where it can be processed, displayed, or stored. Key concepts demonstrated. Digital signal, used by computers for data processing. Analog signal, used by traditional telephone lines for transmission. Modulation, conversion of digital data into analog signals. Demodulation, conversion of analog signals back into digital data. Modem, a device that enables digital communication over analog media. Summary. In summary, the diagram shows how two computers communicate over a telephone network using modems. The sending modem converts digital data into analog form for transmission, and the receiving modem converts it back into digital form. This process enables reliable data communication over analog communication channels and highlights the essential role of modems in traditional data networks.
Ethernet card. Ethernet card, also known as Network Interface Card, NIC card in short, is a network adapter used to set up a wired network. It acts as an interface between computer and the network. It is a circuit board mounted on the motherboard of a computer as shown in Figure 10.9. The Ethernet cable connects the computer to the network through NIC. Ethernet cards can support data transfer between 10 megabits per second and 1 gigabit per second, 1000 megabits per second. Each NIC has a MAC address, which helps in uniquely identifying the computer on the network.
The image depicts a PCI, Peripheral Component Interconnect, network interface card, commonly referred to as a NIC, designed to provide a computer with network connectivity. This type of network card was widely used in desktop computers before modern onboard Ethernet controllers became standard on motherboards. Physical components and connectors. The card features two distinct network interfaces. Ethernet, RJ45 port. The RJ45 port is used for twisted pair Ethernet cables, typically supporting 10 base T Ethernet and, in some models, 100 base TX fast Ethernet. This connector allows the computer to be linked to network devices such as hubs, switches, or routers in a star topology LAN. It represents the more modern and widely adopted Ethernet connection type. Coaxial, BNC, connector. The BNC connector is designed for 10 base to thin Ethernet networks, which use coaxial cables in a bus topology. In this setup, multiple computers are connected along a single coaxial cable segment, with terminators required at both ends of the cable to prevent signal reflection. This technology was common in early Ethernet deployments but is now considered obsolete. Function of the PCI NIC. The primary function of this NIC is to enable network communication by converting data from the computer into network frames, handling MAC addressing and error detection, transmitting and receiving data over the connected physical medium. Installed in a PCI expansion slot on the motherboard, the card communicates directly with the system bus to send and receive network data efficiently. Typical use cases. This type of dual-interface NIC was useful during the transition period when networks were migrating from coaxial-based Ethernet to twisted-pair Ethernet. It allowed compatibility with both older and newer network infrastructures without replacing hardware. Relevance in modern context. Today, such cards are mainly found in legacy systems, educational demonstrations of early networking technologies, industrial or embedded systems still using older Ethernet standards. Modern networks have largely phased out 10 base to in favor of faster, more reliable Ethernet technologies such as gigabit Ethernet. Summary. In summary, the image represents a legacy PCI network interface card that supports both RJ45 and BNC connectors. It highlights the evolution of Ethernet networking from coaxial-based bus topologies to twisted-pair star topologies, illustrating how earlier network hardware was designed to remembering backwards compatibility during periods of technological transition.
RJ45. RJ45 or registered Jack 45 is an 8-pin connector that is used exclusively with Ethernet cables for networking. It is a standard networking interface that can be seen at the end of all network cables. Basically, it is a small plastic plug that fits into RJ45 jacks of the Ethernet cards present in various computing devices.
The image shows an RJ45 Ethernet connector, which is the most commonly used connector for wired computer networking. It is attached to a blue Ethernet patch cable, and the transparent plastic housing allows the internal gold-plated contact pins to be clearly visible. Description and structure. An RJ45 connector has 8 metal pins arranged in a row, corresponding to 8 copper wires inside the Ethernet cable. These pins make physical contact with the Ethernet port on devices such as computers, switches, routers, and modems. The gold plating on the pins improves conductivity and helps prevent corrosion, ensuring reliable data transmission over time. The plastic clip, locking tab, on the connector secures it firmly into the Ethernet port, preventing accidental disconnection during use. Function in networking. The RJ45 connector is used to terminate twisted pair Ethernet cables such as Cat5, Cat5e, Cat6, Cat6a. These cables are used to transmit data signals in local area networks, LANs. When connected, the RJ45 interface enables high-speed communication between network devices using Ethernet standards such as 10 megabits per second, 100 megabits per second, 1 gigabit per second, and higher. Standards. RJ45 connectors follow standardized wiring schemes to ensure compatibility. T568A, T568B. Both standards define the exact order of the colored wires inside the connector. Incorrect wiring can lead to network failures, reduced speed, or unstable connections. Typical usage. RJ45 Ethernet connectors are widely used in home and office networks, data centers, school and enterprise LANs, routers, switches, and access points, IP cameras and VoIP phones. They are essential for wired networking due to their reliability, low latency, and resistance to interference compared to wireless connections. Troubleshooting and common issues. Common problems associated with RJ45 connectors include loose or broken locking clips, bent or damaged pins, incorrect wire termination, cable wear or internal wire breakage. Such issues can result in intermittent connectivity, slow network speeds, or complete connection loss. Cable testers are often used to verify correct wiring and continuity. Summary. In summary, the RJ45 Ethernet connector is a fundamental component of modern wired networking. Its design allows secure, high-speed data transmission over twisted pair cables, making it a critical interface for connecting network devices in local and wide-area network infrastructures.
Repeater. Data are carried in the form of signals over the cable. These signals can travel a specified distance, usually about 100 m. Signals lose their strength beyond this limit and become weak. In such conditions, original signals need to be regenerated. A repeater is an analog device that works with signals on the cables to which it is connected. The weakened signal appearing on the cable is regenerated and put back on the cable by a repeater. Hub. An Ethernet hub is a network device used to connect different devices through wires. Data arriving on any of the lines are sent out on all the others. The limitation of hub is that if data from two devices come at the same time, they will collide. Switch. A switch is a networking device that plays a central role in a local area network, LAN. Like a hub, a network switch is used to connect multiple computers or communicating devices. When data arrives, the switch extracts the destination address from the data packet and looks it up in a table to see where to send the packet. Thus, it sends signals to only selected devices instead of sending to all. It can forward multiple packets at the same time. A switch does not forward the signals which are noisy or corrupted. It drops such signals and asks the sender to resend it. Ethernet switches are common in homes and offices to connect multiple devices, thus creating LANs or to access the Internet. Router. A router is a network device that can receive the data, analyze it and transmit it to other networks. A router connects a local area network to the Internet. Compared to a hub or a switch, a router has advanced capabilities as it can analyze the data being carried over a network, decide alter how it is packaged, and send it to another network of a different type. For example, data has been divided into packets of a certain size. Suppose these packets are to be carried over a different type of network which cannot handle bigger packets. In such a case, the data is to be repackaged as smaller packets and then sent over the network by a router. A router can be wired or wireless. A wireless router can provide Wi-Fi access to smartphones and other devices. Usually, such routers also contain some ports to provide wired internet access. These days, home Wi-Fi routers perform the dual task of a router and a modem switch. These routers connect to incoming broadband lines from ISP, Internet Service Provider, and convert them to digital data for computing devices to process. Gateway. As the term gateway suggests, it is a key access point that acts as a gate between an organization's network and the outside world of the Internet. Gateway serves as the entry and exit point of a network, as all data coming in or going out of a network must first pass through the gateway in order to use routing paths. Besides routing data packets, gateways also maintain information about the host network's internal connection paths and the identified paths of other remote networks. If a node from one network wants to communicate with a node of a foreign network, it will pass the data packet to the gateway, which then routes it to the destination using the best possible route. For simple internet connectivity at homes, the gateway is usually the internet service provider that provides access to the entire internet. Generally, a router is configured to work as a gateway device in computer networks. But a gateway can be implemented completely in software, hardware, or a combination of both. Because a network gateway is placed at the edge of a network, the firewall is usually integrated with it.